Hello students, welcome back to MKG Online Study and e-learning platform. There is a network design so simple that one broken cable can shut down an entire company. No hub, no boss, just devices passing secrets in a circle. This is ring topology. And by the end of this video, you will understand it is better than most IT students. Ring topology, the network that never ends. Let's break it down. Have you ever wondered what a network would look like if it had no beginning and no end? That's exactly what ring topology is. Every device connects to exactly two neighbors, forming a closed loop, like a circle of friends, passing notes where each person only talks to the person on their left and right. A network layout where each device connects to exactly two neighbors, forming a continuous closed loop that is ring topology. Data travels in a single direction or in both directions if it is a dual ring. And here is the wild part, there is no central hub. No boss controlling traffic, just PC1 talking to PC2, PC2 talking to PC3, and so on, all the way around. So, how does data actually find its way? Step 1, device sends data plus a destination address onto the ring. Step 2, every single node checks, is it mean for me? Step 3. If it is not you, you don't ignore it. You pass it along to your neighbor. Step 4. When the right device finally gets it, it grabs the data and often sends a confirmation back. This whole process even has a name, token passing. This is called token passing when a special permission signal controls who can transmit. So, two devices never collide. Before we go further, let's lock in the fundamentals, the stuff that actually shows up in exam and interviews. Every station wires to exactly two neighbors. Signal moves in a single defined direction or both ways in dual ring design. Each station acts as an active repeater. It regenerates the signal before passing it on. Control is distributed. There is no central controller managing the whole network. Access is deterministic. A token or turn-based scheme guarantees every station a fair chance to transmit. Total ring latency is equals to sum of propagation plus repeat delay at every single station. So this is the characteristics of ring name. So in this, the data is transferred in a sequential manner bit by bit around the ring. Note that each repeater will regenerate and retransmit each bit. Next is functions of a ring. A ring can operate as a communication network if it performs the following three functions: data insertion, data reception, data removal. Each repeater also acts as a device attachment point, as the function of data insertion is accomplished by the repeaters. Data is transmitted in the form of packets. Each packet consists of a destination address field. As this packet by a repeater, the destination address field is copied by the repeater. If the destination address field corresponds to the address of a device, then that repeater copies the remaining contents of packet as well. Data insertion and reception can be done easily by the repeaters, but data removal is not difficult. more difficult on a ring. As the ring is closed loop, a packet will circulate on it indefinitely if it is not removed. As the ring is closed loop, a packet will circulate. A packet can be removed by the addressed repeater, or each packet can be removed by the transmitting repeater itself after the packet has made one trip around the ring. The second approach is more desirable. Problems faced in ring topology. If any link breaks or if repeater fails, then the entire network will be disabled. To install a new repeater for supporting a new device, it is necessary to have the identification of two nearby topological adjacent repeater. It is necessary to take preventive measures to deal with the time jitter. Every station adds a small repeat delay, so total delay grows with the number of stations. Large ring gets noticeably slower. Physical adding, removing, or moving a station usually means briefly breaking the loop, which can interpret the whole network. Due to the closed nature of the ring topology, it is necessary to remove the circulating packets. These problems, except for the last one, can be rectified by refinement of the ring topologies. Advantages: predictable performance, simple fault detection, easy setup, less cable. No one computer can monopolize the network because every computer is given equal access to the tokens. The fair sharing of the network allows the network to continue function in a useful, if slower manner, rather than fail once capacity is exceeded as more users are added. Disadvantages. One break equals to total failure. In a single ring, one damaged link can disrupt the entire network. It is difficult to troubleshoot the ring. Adding or removing the computer disturbs the network activity. Data may hop through many devices before reaching its target. Where you will find it in real life. Token ring can be found out in one of the earliest LAN standards using ring-based token passing. So, IBM's token ring was one of the earliest LAN standards. FDDI, Fiber Distributed Data Interface, dual ring for high-speed backbones, and SONET. Rings still keep telecom networks alive today, literally designed so that even if someone cuts a fiber cable, data rerouters the other way around the ring and keep flowing. The SONET pack is most shareable. So modern Ethernet mostly replaced pure ring LANs, but the concept lives on the resilient telecom and industrial network. So next time someone asks you how a network can have no real beginning or end, you will know exactly what to say, right down to how it actually works, what can go wrong, and where it is used. If this made networking finally click for you, smash that subscribe button. I'm breaking down one topology at a time, and trust me, the next one gets even crazier. So students, if you enjoyed this video, then give the thumbs up button, press the like button, share this video with your friends and subscribe the channel. Hit the bell icon. So next topology which we are going to see is star topology. Thanks for watching. Your support means a lot for me.